Good evening, everyone. Thank you very much for joining our Women's Engineering Society Climate Emergency Group webinar. I'm Yihan Hu, a PhD researcher from University of Huddersfield. Thank you so much for Hud-IET Octopus community to help us to organize and distribute webinar for our group. Thank you for the committee members, Philippa, Mohammed, Friend, to help us. I'm one of the members of a Climate Emergency Group Sustainable Sub-group, also was the founder and the first chair of Hud-IET Octopus. So now I will invite the chair of a Climate Emergency Group, to Sally, to introduce our group to all of us.
Thank you. Thanks very much, Yihang. And yes, welcome to an International Women in Engineering Day event. We're fitting in with a whole program of different activities building up to the 23rd of June, which is WES's birthday. So welcome to the evening. Yes, the Climate Emergency Group was set up year before last, and we've had lots of activities, lots of debates, lots of discussions, and we've got a number of working groups that are set up, all working under the climate emergency banner. And if you'd like to move on to the next slide, that shows the aims of the group. So why did we set it up? Why join the Climate Emergency Group, and what's its purpose? Just because together we can influence our employers and colleagues. I think the USP that WES has is that we're genuinely a multidisciplinary and multi-sector group. So the types of conversations that we can have is quite different from some of the fora that I've attended with some of the other professional engineering institutions. So I think in terms of recognizing how we need to collaborate and innovate to be able to crack the climate emergency challenge, WES is really well placed to address that. So the purpose is around knowledge sharing, exchanging that information, playing our part as professionals and being aligned in what we're doing in terms of working with industry. And then we've got quite a cross-section of individuals who are part of the group, and we're all looking to influence the projects that we're working on, the research that we're involved with, the clients and partners that we're working with, so that we're all able to make our own contribution to the net zero challenge. If you move on to the next slide, please. What's the hurry? Well, there's been a whole host of different reports and activities. Just this week, there was another that was published today saying that, this week rather, that was saying that even in the last 5 years, we've not really made any as much progress as we'd hoped to in terms of adaptation measures to address the global warming that is already built in. So even if we went net zero from today, we'd still have all of those impacts, of course, to address going forwards. So the Climate Change Act in 2008, that set the targets, that's been refreshed in Paris, and we've got high hopes of what's going to be discussed in Glasgow in November. So I think over to the rest of the group now to take you through the presentation. Please do post your questions in the Q&A section. And just a reminder that there are other events coming up. We've got another talk on the 29th of June, looking at SDG 9 and 12, looking at embodied and operational carbon, and another two that's on the 24th of June next week, and that's at lunchtime at 1:30. So if you're interested in finding out more, please do go onto the website. Thank you. So don't forget to log your questions into the Q&A section on your screen. Thanks very much.
So here is I will introduce the aim of our sustainable group. So our group aim is to ensure access to affordable, reliable, sustainable, and modern energy for all of us. Today, we have invited 5 speakers, and they will introduce themselves detailedly later. Our panel comes from a wide range of careers in engineering, looking at sustainability from several different perspectives. Find out how we can make our world more sustainable, both at home and at work. Hear about how engineers and researchers are contributing to the fight against climate change. Get some inspiration or easy things we can all do to be more sustainable. Sustainability challenge in the lead up to things we can all do to be more sustainable. So sustainability challenge in the lead up to this event, we are challenging you to see if you can change your habits for a week and be more sustainable. After all the speeches, we will ask questions for all the presenters. We welcome all the audience to type and ask questions from Q&A box. So now, please allow me to invite our first speaker, Eleni, to talk about electric vehicles and electricity networks. Thank you.
Thank you, Yiheng. Hello, everyone. My name is Elaine Mesky. I am a chartered systems engineer, and I work for an organization called SENEX. SENEX is an independent non-profit organization, and we focus our mission on supporting zero-emission transport around the world. Today, I'll talk about electric vehicles and the electricity network, focusing on the environmental cost of road transport and the environmental credentials of EVs, one of the biggest barriers that people cite, and busting the myth about the cost of EVs, and also touch on the network interactions and impacts of EVs. So I think it's quite easy to get lost in the numbers and the degrees C warming or percentage increases and things like that. Why are we talking about this? On the next slide, you'll see a photo. This is Ella Adu Kissi Deborah. She lived in southeast London and died at the age of 9. On her death certificate, it said air pollution is the cause. Respiratory failure at the age of 9 due to air pollution. So it's not just about carbon emissions. Road transport contributes to nitrous oxide and particulate matter emissions. And all these are vastly better in electric vehicles. There's obviously no carbon emissions or nitrous oxide emissions from EVs, but the particulate matter is also better. And it's not just at the tailpipe that the electric vehicles are better. If we go to the next slide, we can see that when comparing the life cycle analysis of the CO2 emissions, even in the worst case when the network of the country might not have a very good carbon intensity due to poor proliferation of renewable energies, even in those cases, it's still better than petrol and diesel equivalents. So we know that the environmental credentials stack up for electric vehicles, but what about for people like you and me? How can we afford electric cars? It's true that the upfront cost is more expensive. So you can see at the bottom there, 18% more expensive if you're buying a new electric to a petrol or diesel. But when we consider the total cost of ownership, including fuel, including tax, insurance, servicing, and the fact that there's such a growing market for secondhand EVs, the total cost of ownership is on par with petrol and diesel already. But more than that, and more sustainable and cheap alternatives exist out there, such as subscription models, On2 is an example, and car clubs. Co-cars is an example of that. So I have, just last month, I got my first car and I pay monthly. I'm only tied in a month at a time, and it includes all my servicing, roadside assistance, free charging on 3 public networks, and as soon as I'm finished, as soon as my mileage reduces, perhaps over the summer, after the summer, I can return that vehicle. So these are some options where it can be much quicker and easier to transition to electric vehicles. With car clubs, you book the hours or days that you need it, rather than 90% of the time it's sitting, not used on your drive. In terms of the costs, the fuel I want to touch on. So 86% cheaper on average, but on the next slide, we can see that actually you can even be paid to charge. So the Agile Octopus energy tariff, when there's excess wind energy being generated or solar energy, people who are on this tariff and use the smart, for example, OMI cable, can be paid to charge. This because this supports the grid, it supports balancing supply and demand on the grid. And why curtail the wind energy when you can make use of it in the batteries that are sat in people's homes, in their cars? So I've touched there on the impacts on the electricity network, and I want to touch again on the next slide about the impact on the distribution network. So the light blue line shows the 24-hour demand profile. This is on an 11 kV feeder, so it's the aggregated profile of many houses. You can see in the morning a slight kind of blip from when people shower to get up before they go to the office, pre-COVID times, and then in the evening the bigger peak demand when people come home, do their cooking, and maybe put the TV on, put all the lights on and things like that. Now, what we found on a number of innovation projects was My Electric Avenue and Electric Nation is that most people plug their car in at home when they get home in the evening. This doubles the peak demand and can cause, when about half the people on a network have electric vehicles, that can cause the network capacity, which is shown by the green line here, to be exceeded. That's obviously a problem. It could cause faults, but what we can also see is that there are times outside that peak where there's plenty of capacity on that distribution network. So what we need to shift that charging with the smart charging cables or charge points and with tariffs. In those same trials, we tested this out and found that the customers, the EV drivers, were satisfied. They still had the charge they needed because most people don't go out until the next morning again, or if they do, it's for a short journey. And the network was protected. So we can delay the need to reinforce networks and the costly reinforcement with those technologies. And in the future, we'll be able to go one step further with vehicle to grid. So the vehicle's actually providing power back onto the grid to support the networks. That's all I have time for today. Please put your questions in the box below. They are my contact details, and I'll now hand over to Nancy. Thank you very much for listening.
Thank you. Hello, briefly about me. I graduated as a mechanical engineer and have worked for manufacturers of boilers, renewable heat pumps for over 20 years. My career has included management roles in R&D, product management, and also as commercial director. I'm now a consultant helping an organisation called Energy Sprong, where I search for products for net zero housing retrofit programmes. Thanks. Next slide. So first, a bit of context. The UK's 27 million dwellings are old and energy inefficient. They're among the worst in Europe. Over 75% of our homes are over 40 years old, and they only have a moderate energy efficiency of band D or worse. So we've done a lot of work in recent years to decarbonise electricity and move to renewable sources, but actually we use a lot more thermal energy than we do electricity, and we've got a lot of work to do to address carbon emissions from heating. Next slide, please. So about 85% of UK homes are connected to the mains gas grid, and 23 million homes are heated by gas. And herein lies the problem. Our home heating accounts for about 17% of UK carbon emissions. But the carbon intensity of natural gas is significantly higher now than the renewable energy electricity. We've got a vast gas infrastructure, and gas is cheap, thanks to a lot of government rebates. We sell and install about 1.7 million new gas boilers each year. But those net zero targets means we've got to urgently rethink how we heat our homes. For instance, the IEA, the International Energy Agency, recommended that no new fossil fuel boilers should be sold and installed from 2025. So that's a really big challenge. Next slide, please. So what's the future of heating our homes? Industry generally agrees there's no one-size-fits-all solution to reaching net zero, and extensive electrification of home heating with heat pumps is required, as well as hydrogen gas boilers. Many companies are racing to develop hydrogen boilers, and a small number of field trials have started. However, full rollout of hydrogen-ready boilers isn't actually expected until the 2030s. Heat pumps, on the other hand, they're not a new technology and have been sold for many years, and there are probably around 130,000 working at the moment in the UK, and last year 36,000 were fitted. But government's got a massive ambition of to ramp up to 600,000 a year by 2028. That's a massive increase. Next slide, please. So I just want to briefly describe two types of hydrogen before I explain more about heat pumps. Blue hydrogen uses natural gas in a steam reformation process, and when it's burned in a gas boiler, will have an end-to-end efficiency, according to LETI, of about 58%. So many people are advocating green hydrogen instead. This is formed by electrolysis using renewable electricity. But at the moment, green hydrogen only accounts for less than 1% of hydrogen production. So while it could be useful for sectors such as process industries, it's unclear if it could be generated in the necessary scale for domestic heating. Next slide, please. So a quick run through the types of heat pumps. There are three main types that you might come across. The first one is a ground source heat pump that uses pipes buried in the garden to extract heat from the ground. There's a mixture of water and antifreeze in those pipes, and heat is absorbed into the antifreeze fluid and passes through the heat exchanger into a heat pump. The ground stays at a pretty constant temperature under the surface, so that heat pump can be used easily throughout the year. Air source heat pumps are the most popular choice at the moment in the UK, and they represent about 85% of the market. They absorb heat from the outside air, and they don't require large ground areas. And there are siting rules to help limit the impact of noise on neighbours. And water source heat pumps are pretty rare, and they extract heat from open water such as rivers, lakes and canals, and also from seawater. And I say they're rare because not many of us live by open water. Ground and water source are more efficient than air source, but are generally more expensive. Next slide, please. So I just want to give a brief explanation for engineers in the room how a domestic heat pump works. A refrigerant in a closed system is circulated and compressed to high pressure, high temperature. The temperature is then released to the heating system via a heat exchanger, and the refrigerant condenses back to a liquid state. Its pressure is then reduced via an expansion vessel, and it passes to the evaporator, where it's warmed by the air or by a network of ground pipes. And that circuit starts again. Heat pumps are very efficient. So for every unit of electricity used to drive the compressors and pumps, a heat pump will produce around 3 to 4 units of useful heat. So they're about 300 to 400% efficient. And at that level, the carbon dioxide emissions are around 70% lower than for gas boilers. The water source the source temperature from an air source can be as low as -25, and for ground source, typically around 8 to 10 degrees. Next slide, please. So I just wanted to show a couple of final slides to give you an idea of what's involved. On this slide, you can see an air source heat pump outdoor unit and the internal pipework, hot water cylinder, buffer vessel, and the square unit is a hydraulic box containing valves and expansion vessels. Next slide. This might be of interest to people on the gas network. This is a hybrid system that combines a heat pump and a gas boiler. It chooses either the cheapest or the lowest carbon operation mode. And next slide. This system is for low energy new build homes. It combines a heat pump with a fresh air ventilation system. Heat is extracted from the stale exhaust air to increase the heat pump efficiency. And final slide, please. This is a ground source slide showing the installation of a borehole drilling machine to give you an idea of scale. You can see that you do need a little bit of land space to get that drill in there. So that concludes a whistle-stop tour of the future of heating of our homes. Thank you very much. And I'll now hand over to Linda.
Good evening. As you can see from my job title, I don't actually work in the energy sector. I work for BT as a programme manager. I did a degree in electronics and microcomputer systems and joined BT more years ago than I care to remember. The key thing is that I did do a degree in engineering, and therefore I understand a bit about how things work. My husband has a degree in environmental studies, and some of what he did as part of his degree has driven the changes that we've made to our house to make it more energy efficient. We're both interested and passionate in the environment, carbon reduction, and what individuals can do to reduce carbon and do their bit for the environment. The things that we've always done to save money and to reduce our energy usage are to switch things off, unplug things. With our old microwave, I used to unplug it when we wasn't in use, but I gave up doing that because with a new microwave, I actually have to put the time in before I start it. So whatever you do, it has to make your life easier, not harder. We also have thermostatic radiator valves in our house. That's really boon to us. It means that when I finish work on a Friday evening, I turn the thermostatic radiator valve off and then don't turn it back on until Sunday evening. As a result of all of these things that we do, the little things that we do, we use 25% of the electricity and 45% of the gas for a normal house this size. So what have we actually changed in our house? When we purchased our house, it was sound. Bricks, mortar, roof. It even came with cavity wall insulation and some roof insulation. Having said that, the windows and doors weren't great. I could push my fingernail into the window ledge. And the first Christmas we were here, my sister-in-law's darling dogs came to stay. They did such a good job scratching the back door that we couldn't open and shut it by the time she left. We ended up having to use the patio doors to get in and out of the house. The following summer, everything was replaced by UPVC double glazing. So we got rid of the single glazing, we got rid of the wooden frames, we got rid of the maintenance. I don't need to paint them. I hate painting windows, particularly as we have mock Georgian windows and they're a nightmare. Because we have a passion for the environment and we could do so, and it was in the days before my husband changed to work in the environment and we felt flush. We got hot water solar heating. It was installed 20 years ago. It has a payback period of 10 years. So I think it was a good investment. There were a number of drivers for it, saving money, but also my husband was job hunting and he wanted to be able to say, I don't just talk about doing energy saving and efficiency things, I also actually implement them. As part of his degree in environmental studies, he came home one evening and said, we need to change the way we use our house. The sliding patio doors that I mentioned earlier, they were in the dining room on the south side of the house. They get all of the solar gain. It's a lovely warm room, but we never used it. We used the lounge on the north side of the house. So back to the UPVC people, more patio doors, and we swapped things around in the house. And just because I can mention it here, a few years after we moved in, my flat in London, finally came out of negative equity. And I achieved my childhood ambition of owning a sports car. We bought a Lotus. Not the most practical car in the world. It's environmentally friendly. And most of all, it's fun. Next slide, please. As part of my husband's job, he managed to take part in a trial with the Energy Saving Trust for a home action plan. There were quite a few recommendations, but I'd really just like to touch on two of them. We have a band C house, and I don't think we can move any higher than a band C, no matter what we do to the house, unless we knock it down and rebuild it. But the changes that we've made have gradually reduced things. So we've installed PV panels on the roof. Prior to the PV panels, we used 2.6 kilowatt hours for the previous 12 years. After we installed them, we used 2.0. The average PV generation is 1,720 kilowatt hours per annum, and we export on average 1,058 kilowatt hours. The other thing that we did, which was a major change, was to replace the boiler from a standard one to a condensing boiler. Reduced our gas usage by a massive 25%. It went down from 13,303 to 9,890, which I think is pretty good. With the exception of the electric PV panels, I think that all of these changes are things that anyone could make to their house. I'd now like to hand over to Laura Brown, who is the Energy Research Programme Manager for Newcastle University. Thank you.
Thank you, and thank you for the introduction. Yes, my name is, good evening everyone, first of all. My name is Laura Brown and I am indeed the Energy Research Programme Manager at Newcastle University. I'm a chartered engineer and member of the IET and the Women's Engineering Society. I'm also the team leader for the SDG7 team of the WES Climate Emergency Group. And I'm delighted today to speak to you tonight about how cities can respond to the climate emergency. And I'm presenting the example of Newcastle upon Tyne, the city where I work and live. So where is Newcastle? First of all, for those of you who don't know, it's in the northeast corner of England in the United Kingdom and has a population of about 300,000 with approximately 125,000 households. Unfortunately, more than 16% of those households, which equates to about 20,000 houses, live in fuel poverty and struggle to pay for their electricity and gas bills. So I think before you tackle any sort of challenge in engineering, you really need to understand what the problem is. So greenhouse gas emissions data can really spotlight where the real problems lie. And in this Our World in Data slide, we can show exactly why we should be tackling energy as one of the solutions for the emergency. Energy accounts for 75% of all global greenhouse gas emissions. So in short, if we tackle energy, then we're going to make a positive impact to reducing the human contribution to greenhouse gas emissions. Next slide, please, Laura. So when we establish just how much the city of Newcastle is actually contributing to this, we look at the scope, and this gives us an idea of the scale of its climate emergency challenge. In 2018, it was estimated that the city emitted 1.8 million tonnes of CO2 equivalent greenhouse gas emissions across all of the designated scopes. And we define these scopes in the UK using the Global Protocol for Community Scale Greenhouse Gas Emission Inventories, or the GPC. So Newcastle's approach is to prioritise action on the biggest causes: energy, transport, adaptation and sustainability to some degree. And the city has developed a Net Zero Newcastle 2030 action plan. And I'm going to talk you through with you a few of these initiatives that they are planning. So when it comes to energy, the primary strategy of the city is to really try and reduce the city's demand for energy in the first instance. So reducing energy consumption in our homes, non-domestic buildings such as hospitals, universities, schools, as well as shops and other commerce, and tackling this through a range of measures such as fabric improvements, insulation and passive cooling. And secondly, the city is planning to increase significantly its own citizens' generation of energy from renewable sources, increasing deployment of rooftop solar PV and targeting installing heat pumps in homes and non-domestic properties. And the city is going to build on its success with district heating by targeting 20% of the homes in the city and over 70% of the non-domestic properties being heated through low carbon district energy networks by 2030. And because of the scale of this challenge, the city is also looking to innovation as a way to really respond as quickly as they can to the emergency. So green hydrogen blended into the gas network, for example, and also a range of smaller impact interventions such as biofuels and biogas. When it comes to tackling transport, the city also has ambitious plans. This includes encouraging the take-up of low carbon emission vehicles, not just for personal citizens, but also for freight and public transport. And they also plan to enhance the sustainable transport modal shift that's essential to really encourage people to use sources of net zero transport, such as walking or cycling, and transitioning to electrical vehicles and buses that can be fueled with renewable electricity or biofuels. And finally, again, looking at efficiency and journey avoidance as a way to reduce impact, encouraging more working from home, reducing the number of face-to-face meetings, and also increasing the efficiency of the journeys we do make by increasing carpools and encouraging a car sharing, car club rental schemes. While these measures we've mentioned surely reduce the greenhouse gas emissions from the city, there are a raft of additional benefits. Some of these changes include opportunities for growth in the local economy, producing new green industries staffed by a local workforce, and then also taking some climate action will prevent extreme climate events, so we'll avoid expensive repair costs for the city. And there is a wealth of benefits for the individual citizens. The fabric improvements to buildings will reduce fuel bills and hence help people lift people out of that fuel poverty I mentioned earlier. The quieter streets and, very importantly, much cleaner air will provide healthier and safety will provide health and safe benefits. And citizens will have healthier lifestyles with more active travel and healthier diets. An improved local environment with more biodiversity, cleaner water and more green space for the city's citizens. So that was my very swift overview of how Newcastle as a city is approaching the climate emergency. And I look forward to working with the city and its businesses and citizens in achieving these goals. So thank you very much for your attention. I'm now going to hand over to my colleague Beth, if she's there. She is, thank you.
Yeah, thanks, Laura. Thank you. If you could go to the next slide, thanks. And really, I just left my I left my picture there because look at how well I matched with the WES colors. I mean, it just fits perfectly. Anyway, that's just a happy coincidence. So yeah, today I'm going to talk about the importance of context when addressing SDG7 globally. My name is Beth Tennyson. I'm a postdoctoral researcher at the University of Cambridge, but I'm also wearing a couple different hats as the country program manager at Cambridge's Center for Global Equality and Climate Compatible Growth. And I'll maybe touch on that a bit. If you have any questions about that, let me know. I'm zooming out and looking at some global solutions, but actually in order to look at global solutions, I actually need to zoom in. So just to recap what we saw now, we saw a lot of local solutions and appropriate solutions for those regions. But if we're going to look at the globe, it's not a one size fits all. And that's kind of what I find very interesting is when you have certain solutions, they only work in certain regions. For example, with heat pumps, that doesn't necessarily make the most sense if you're in your place where it's always warm. So just as a very one-off example. So I'm interested in how do we help lift up the bottom up of the billions of people that don't have access to electricity or energy in general, and how do we make sure that they get access but in a climate compatible way. Next slide, please. So in order to do this, I'm going to actually zoom way in and look at a case study. So this is a work that we've been doing in collaboration in Ethiopia, looking at solar powered water pumps. I want to emphasize here that this is a place-based solution. It was identified by this community in Ethiopia that in Bahir Dar, that there was a lack of, and this is due to climate change issues, there's a lack of predictability in the water source now, and solar powered irrigation was something that made sense for this community. So what you're seeing is a solar panel out in this field, and on the right is a storage of water tank, and that's being pumped in and then spreading around throughout the field. Next slide, please. So the importance of when you're doing a place-based solution is to know your location, and that's not necessarily geography, although it is very important, particularly since we're looking at solar. What type of sun are we getting there? Where is it located? What's the terrain like? That's going to be important for thinking about different types of crops. Next slide, please. It's also really important to know the context of your area. So a lot of this was data taken within the project of how much solar are we getting throughout the year? for example, the annual solar patterns in that region. Then we need to look at the pump design. What's the water source there? How much is they call it the head of the pump need to be? How much power and water output do you need to pump through these? These are all questions that we've had to ask community members based on the previous usage of water. Finally, also water allocation. What are they using that for? A lot of times in these types of communities, what ends up happening is they irrigate for certain times of the year, but then in other parts of the year, when it makes the most sense for them, they actually take they would take the solar panel home and use that for electricity. So it's not just a irrigation system in that sense, it's actually a source of electricity when useful for them. So we're trying to get this one size fits all within this type of community. And it goes way beyond just this type of context. What's the crop type? That depends. Not all crops take the same amount of water. How much rainfall is that region getting? What are the water sources? Is it coming from a river? Is it coming from a well? Is it the ground table water? Also, what's the competition in market? Next slide, please. When we're looking at the competition in market in particular, this is what we have out there. There's pulleys, which offer a 3.6 labor hour per kilogram of water versus the solar powered water pump. And this is really what the challenge is that we're trying to combat, is how do we get away with this labor per hour, which actually highly affects, and this adds in the social aspect, kids and women primarily within these communities. So instead of having to go fetch water, if it's very far away, they would end up being able to spend that time actually going to school. So it goes well beyond just energy access, but moves into the social aspect. And not only is there water pumped fetching, but there's also petrol pumps, so solar powered pumps that are just powered by solar, but then there's also petrol pumps that are competition because of access. However, what you find here, and that's on the right, people waiting in line, they also need to not only fetch water, but they also have to fetch petrol. And that's the beauty of solar, is having this very direct, not needing to go find some sort of fluid or fuel for your pump. So there were a lot of benefits that we found, okay, there's beyond just energy access. And so that made this solution a very nice one size fits all, but you can make the best solar powered water pump in the world. And if it doesn't work for the users, it will never take off, and what's the point? It's just trash. So it's important that, so what we're doing now is surveying the community, asking them what they need. We're finding that lighter solar panels for mobility will be very useful. So we're looking into making flexible solar panels in order to do that. So there's a lot of things that kind of underline all of these solutions. And I think it's important that we note that we need to take these communities in mind when coming up with solutions. So finally, last slide. Let me just summarize. This is the team that's been working on that. We've been working in collaboration with Bahir Dar University, and that's where all of our PhD students are located. And it's been done in the participating institutions, Bahir Dar University, University of Cambridge, and then the sort of fabric behind that is the Center for Global Equality. And thank you all for listening. And I think I'm gonna leave it off to Yi-Hang, we're gonna go to the panel session. Thanks.
Thanks, Ben. Well done. Thank all our speakers for their interesting and informative presentations. I can see a lot of interesting questions come out. So thank you for all the audience to ask so many interesting questions. Some questions are answered by our presenters online, and some are still opening. So the first one is from Nigel to Nancy. So Nancy, are you there? Nancy, hi Nancy, 400% efficient seems mind-blowing. Can you please explain it again?
Yeah, I probably skipped over it a little bit quickly, didn't I? There was one moment when the timer was telling me I had a minute left. So really, it's using the thermodynamic principles and the law that the energy is energy must flow around a system, and also the working pressure and temperature, utilizing the working pressure and temperature of a refrigerant. So by compressing it, you're able to transfer that energy and towards the heating system. And by using the working principles of a refrigerant and its temperature and its pressure to be able to generate and transfer heat energy to the building. So the amount of electrical energy that's consumed to drive that compressor and any pumps in the system is a lot lower. Of course, you can generate a lot higher heat ratio compared to the electrical energy you're utilizing. Not most elaborate explanation, but hopefully that slide helps explain a little bit further the thermodynamic principles of working refrigerants.
It's a fridge in reverse, isn't it?
Of course, yeah, that's one way of thinking about it. So you're taking energy out of the air or the ground, and you're compressing and sort of squeezing that energy to be able to use it usefully and transfer it to your heating system. The thing one additional point to point out is that you're generating water temperatures for your heating system, typically around 35 to 50 degrees C. A boiler system normally is sized for around 75 to 80 degrees C. So for a retrofit situation, you will need to take care of the heat losses to reduce the energy load on the building, and possibly even upsize or upsize your radiators. I hope that helps.
Okay, so Nigel, I hope Nancy answered your question. So the next one, let me see. The next one from Paula to home heating. I think that's for Lida. So I have tried to look for people to get home survey and field. What can be done to accelerate change?
I have to say, this is one of the points that my husband is very frustrated about. A few years ago, the government pretty much withdrew everything that they needed in order to do home efficiency checks, etc. I would start with the Energy Saving Trust website, and I will see if I can get hold of him and come back. There is one more site that you could have a look at. What I'll do is I'll put it into the chat.
Yeah.
Maybe I can. Sorry.
Maybe Nancy can add to that as well. But I'm always going to give an answer to Paula. So Nancy, you go first.
Thank you, Paula. Yes, in terms of getting a home survey and trying to look at new or different technologies, whatever technology that is you're interested in, EST, like Linda said, is a good start, but also the MCS scheme, the microgeneration certification scheme, is the place to go to look for accredited installers who will size and select the right system for your property according to the industry standards, let's say, and accredited standards.
Yeah, and the other option is there's companies usually associated with estate agents, actually, because to buy and sell a home, well, to sell a home in the UK just now, you need a home energy pack, don't you? You need an assessment of the energy efficiency of your home. So even get one of those agents to come out and do that can be as much as £100, unfortunately, because to make that assessment. There's sunshine in Newcastle for once, so apologise. So that's another route, Paula. Or you can get your friends who are in the Women's Engineering Society to come around and say, you don't want to do that, you want to do this.
Yeah, thank you. Thank you, Lida, Nancy, and Laura. I hope they answered your questions. So the next one is from Olalami. I hope I pronounce your name well. So the question is, how do you think we can ensure the actualization of future 100% electric vehicles transportation network? I think this question is to Eleni.
Yes, thank you. So there's two things already in place that are helping. One is the OLEV, Office of Low Emission Vehicle Grants for new electric vehicles. So that's the reason why we have quite a good uptake already in this country. The other thing that will help a lot is the ban on the sale of new petrol and diesel cars and vans from 2030. And then I think the things we need on top of that are scrappage grants to support the people who have the oldest and dirtiest vehicles to get those off the road. And things like that have existed for taxis in London, for example, when the new licensing rules came in that all new taxis and private hire vehicles have to be low emission capable. So, you know, things like that could translate to other private vehicles. And then the innovative business models for this subscription ownership for car clubs. So car clubs can reduce the number of cars on the road from 6 cars previously to 1 car with the car club, because you know, by sharing you can have fewer cars. And then we need to think bigger picture as well, so not just cars but mobility in general. So things like e-scooters can help, much better public transport is needed, better design of towns and cities and pedestrian zones, and things like home working. With home working you don't need a car as often as you did before, so you don't need as, say, if you had 2 cars in the household, I know lots of people that have gone down to 1 car in a household and things like that. So yeah, we really need to think outside the box to the whole mobility solution. Thanks for the question.
Yeah, also I have ideas. In the future, if we want to actualize 100% electric vehicles, we have to add more energy storage systems to our grid, because, you know, electric vehicles, we need to charge and discharge maybe every time. It will give a very high load to our grid. So in the future, we have to add more energy storage systems to keep our network stable. I think that is another solution to actualize the 100% EVs. So the next question is for Laura. So how do you get buy-in from the public?
Okay, so I guess this is a question about how do you talk about the citizens and what you're going to do to their city. How do you make sure the citizens, that's something the citizens want? So Newcastle has got a long history of being a pilot city for a lot of weird and wacky ideas with regards to transport and energy. And we've run a lot of national trials of a whole lot of technologies. And we're currently running the council's running the government's the government's heat pump trial in homes, 600 homes with Eon Energy. So the city's used to being practiced on, but I think the main way to bring people with you on the journey is to explain the benefits. I mentioned, Paula, the number of people who are living in fuel poverty in the northeast. The whole of the northeast region is like it's markedly different than other more affluent areas of the country. So explaining that the changes will help quality of life is very important. It also save money as well, so helping the local economy, helping individual households and helping the local economy with new jobs. So it's about explaining educating, explaining and making sure that the benefits that you are gaining are shared by all, not just by a few big corporations, shall we say. That is what we've got with the current energy system.
Okay, thanks, Laura. I hope she answered your question. So next question is for Ben. Okay, he say from Seth.
Yeah,
okay.
I can answer that. I'll go ahead.
Yeah, please.
Thank you. Thanks, Seth, for your question. I think it's quite exciting. So I don't know if everyone's read that, but like, how would the implementation of rapid solar panels impact culture and society in general? So I think without having to fetch water, gasoline, that adds time for productivity. But I'd like to say that, you know, more innovation would happen. So I won't predict what would happen with all that extra time that's enabled. But hopefully, one of the things that's suggested is that with these solar powered water pumps, you'd be able to have better predictability of your water supply, which would then in turn add more productive crops. So hopefully there'd be more income coming in. Hopefully there'd be more productive time for learning and education, and more time for innovation and access So those are just some basic social hopes that I'd see, but I also think innovation would happen, and it would be kind of amazing to see what kind of innovation could occur. So yeah, it'd be exciting to see. Thanks.
Thanks, Vance. So next question is for Ilani again. So Ilani, you're popular. So he from Ola Lamy. So he asked, do you have any ideas if the price of electricity will decrease or increase when 100, I think, renewable energy systems or 100% electric vehicles is achieved? Do you have any ideas?
Great question, and a very difficult one. With my crystal ball, all I can say is it could be either way. It really depends on how we roll out that 100% renewable energy and 100% EVs. So if we don't think and plan ahead, it could be very expensive, as the graph I showed with the peak demand doubling. So if we just let things happen as they are, that could be very costly. We need to reinforce all those networks. But by using smart technologies like smart charging cables, charge points, and vehicle to grid technologies to balance the grid, we might not have to reinforce at all, and we can even support the reliability of the network and things like that. Probably it will take some time and expense to get all that right. It requires definitely a lot of people in the industry, new standards, new regulations, but I don't think it needs to be more expensive. Obviously, renewable energy is free, so we're not paying for the wind or sun. So in that way, it's free. And in terms of the environmental costs, that we don't pay for the carbon in the fossil fuels. We pay for it with the climate change and climate disaster. So I think from that perspective, it's definitely cheaper. But yeah, very difficult question in terms of how your bill will look.
Okay, thanks, Ilani. So I received information from my colleague, and because it's very tight on time, so maybe we will ask one or two more questions, and okay, I will pass to next step. So so only two questions anymore. The first one is from Patrick. What does the panel think is the biggest thing that need to change for us to meet the carbon reduction targets we need to achieve? Who want to answer these questions? I think for all of our panel.
So maybe we rapid fire. Should we rapid fire? Okay, I'm going to pass it. I'll start and then I'll pass it. Okay. So I guess based on my presentation, I would say there's not one thing. It's a whole plethora of solutions, and there's not one thing that can be done. However, one thing that is kind of prevalent throughout is human beings, and it's going to be behavioral changes, and I think that's going to be probably the biggest thing, is just an acceptance and a collective action, and all on the same page with moving in the same direction with the same goals. I think that's what we can do. Laura, what do you think?
Yeah, so I think you're right. Behavioural change and a policy of paying for the pollution that you make. So if you're using a polluting fuel, you've got to pay a lot more, and then you're disincentivizing people to use petrol, and you're incentivizing them to use a cleaner solution, for example.
Thank you, Vance. Thank you, Laura. Yeah, let's move to the last question. Let me see who is the lucky guy. Okay, so the question from Nigel. Energy efficiency measures are one way to reduce our energy usage. However, the greater challenge is to replace existing carbon CO2-based energy conversion. For example, transport, industrial, and domestic heating with carbon oxygen-free energy. Do the panel feel such a change is feasible within the next 2035 or 2015 timeframe? Any ideas?
Nancy?
Yes, I do. We just need to look at what we do at home and take responsibility for ourselves. But yes, I do. I think it's feasible.
It's being driven by government at the moment with policy changes, and that is genuinely the only way to make people do things, is to actually change the policy. You can have as much will in the world and do things like my husband and I do to reduce the electricity to 25% and gas to 45%. But without government-backed incentives and making things illegal, you're not going to get there. Sorry.
Okay, thank you all. So I think it's time to move to our next steps. So at last, I should remind all of audience that our next meeting is on the 24th at 1:30. I think you will have information from Sally at beginning. So next, I'd like to invite our collaborator, the chair of Hud-IET Octopus, Mohammed Atif, to give us thanks to all of us. Please.
Hi, I can't turn my camera on. It's saying host has turned it off. So maybe if you can help me with that. I think we are running out of time, so I will quickly just do this. Thank you. My name is Mohammed Atif, and I'm chair of Huddersfield IET on-campus society. In case you don't know what Huddersfield is, it's a student-led branch of IET and based at the University of Huddersfield. Our purpose is to organize professional development opportunities for all undergraduate and postgraduate students, but our events are open for audience out of the university as well. I've been asked to wrap up this evening's event, so first of all, I would like to say a few thanks to Sally Sudworth, Laura Brown, Ellen Meske, Yiheng, Nancy Johnson, Beth Tennyson, and Linda Moshe. For all of your presentation were really interesting, and I certainly enjoyed them listening, and I'm sure the audience liked them too. Thank you, Yiheng, for hosting today's event and running the Q&A session. I would also like to thank you all of the people who are helping us advertising this event on behalf of IET and WES. And also, I would like to thank Lydia and IET for setting up registration and providing Zoom webinar. And thanks to Philippa Hazel for the past chair of Huddersfield IET, who was a big help organizing this event. And finally, thank you to the audience for attending this evening's event and showing a wonderful interest in the topic and asking for many thought-provoking questions. And last but not least, if you are interested for our future events, you can see the links in the chat area. You can visit our websites, IET and WES separate websites, and you can find our next events. And you can also find the email in case you want to contact us. And lastly, this session was recorded, and we will make sure that link is available to everyone in case you missed something. And I guess it's time to say goodbye from all of us for this IET and WES. Have a wonderful evening. Take care.
Thank you.
Bye.
Thank you, everyone, for joining us this evening.
Hi, thank you.
Thank you.
Thank you.
Have a good night.
Yeah.
Thank you.
Bye-bye.